Hello everyone, welcome back to my YouTube channel. In today's video, we are going to discussion about that one of the most important topic in engineering department, that is GD&T. This is not like engineering department that any industry field that is most important in quality engineer, industrial engineer and engineering. So let's discussion about the GD&T. So GD&T stands for geometry dimensioning and tolerancing. So GD&T, what is GD&T? So GD&T stands for geometry dimensioning and tolerancing. So it is a standardized system used on engineering. So it is a standardized system used on engineering drawing to communicate the required size of a part, the allowable variation in size, the required shape, the required orientation, the required location, the required relationship between different features. In simple word, GD&T tells the manufacturer how much a feature is allowed to vary, and tells the inspector what the requirement to finished part must satisfy. For example, suppose you have a plate with a hole. A nominal drawing might say hole diameter diet 10 plus or minus 0.1 mm, and this control the size of the hole. But it does not completely tells you how round the hole must be, whether the hole must be perpendicular to the surface, whether the hole must be exactly the specified location, whether the hole axis can be tilted. So GD&T allows us to control the geometric requirement. Then why do we need GD&T? Consider two manufacturer parts. Both parts may have dimension within their specified limits, but one may still fail to assembly properly. For example, a shaft should fit into a hole. The shaft diameter may be correct and the hole diameter may also be correct. But if the hole is tilted or incorrectly positioned, the assembly may not work. So GD&T solves this problem by controlling the geometry and relationships of feature, not just their dimension. So the main advantages of GD&T are improve product quality, improve interchangeability, reduce manufacturing cost, reduces unnecessary time tolerance, makes drawing easier to interpret, improve inspection, improve communication between designer, manufacturer and inspector, helps ensure properly assembly. So basic idea of tolerance. So a tolerance is permitted. A tolerance is the permitted variation from a specified dimension. For example, 50 plus or minus 0.05 mm. The acceptable range is for example 50 plus or minus 50 by 0.05 mm. The acceptable range is maximum size is 50.05 mm and minimum size is 49.95 mm. Therefore, the tolerance 50 0.5 minus 49, so 0.10 mm. The traditional dimension tolerancing mainly control size. GD&T additionally control geometric characteristics. GD&T symbols system. GD&T symbol system. GD&T uses specified symbol to represent different geometric requirements. There are five major group of geometric controls. One is form, another is orientation, another one is location, and profile runout. Let's understand each one carefully. First one, form tolerance. What is form tolerance? Form controls the shape of an individual feature. For the main form controls are straightness symbols this and control straightness, flatness symbol and flatness control the flatness, circularity circle that is the roundness, control roundness, cylindricity cylindrical shape. An important point, form tolerance generally do not require a datum. So another important term, form tolerance generally do not require a datum. So let's examine each. Straightness. What is straightness? Straightness control how straight a line or surface must be. So symbol this. Imagine a shaft. Imagine a shaft. Ideally its center line should be perfectly straight, but the manufacturer may produce a slightly bent shaft. So GD&T can specify how much bending is allowed. Example: if the shaft has straightness 50 micron 0.05 mm, the control line must remain. So the control line must remain within the specified straightness tolerance. Application: straightness is shaft commonly used for shaft, guide rails, and sliding surfaces, edges, machine surfaces. Flatness. So flatness control how flat surface must be. Symbol: this is the flatness. Suppose you have a machine plate. So flatness control how flat a surface must be. Symbol: flatness. Suppose you have a machine part. Suppose you have a machine plate. Flatness. Suppose you have a machine plate. The surface may not be perfectly flat. It could have bending. So suppose you have a machine plate. It could have bending, wrapping, high spots, low spots. If flatness is specified as 50 micron, means 0.05 mm, the entire surface must lie between two parallel planes, separately by 0.05 mm. Important flatness does not require a datum, so it controls only the surface itself. Then circularity or roundness. Circularity control how close a circular cross section is to a perfect circle. So symbol this. Imagine a cylindrical shaft. A actual cross sectional might look slide like an oval. So imagine a cylindrical shaft. An actual cross section might look slightly like an oval. Circularity control this deviation. Example: a shaft diameter 20 mm with circularity 20 micron, means 0.02 mm. So most of each circular cross sectional within the specified circularity zone. Application: bearings, shafts, poles, rotating components. So another name is cylindricity. What is cylindricity? So cylindricity controls the completely cylindrical form of picture. So cylindricity controls the completely cylindrical form of a picture. Symbols this. It controls the combination of cylindrical shape of a picture. It considers variations such as roundness, straightness, taper, overall cylindrical form. Example: for a precision shaft, cylindricity may be specified to ensure the entire shaft behaves like a true cylinder. Important: cylindricity does not require a datum. So orientation tolerances. Orientation controls how one picture is oriented relative to the another picture or datum. The main orientation controls are parallelism, perpendicularity, angularity. Parallelism, perpendicularity, angularity. Parallelism. So parallelism is the orientation tolerance. The orientation. Then another new topic is orientation tolerance. Orientation controls how one picture is oriented relative to the another picture or datum. The main orientation controls are parallelism, perpendicularity, angularity. So first one is parallelism. Symbol this. Parallelism controls whether a feature is parallel to a reference datum. Parallelism controls whether a feature is parallel to a reference datum. Imagine two surfaces. So ideally this one is datum, another is controlled surfaces. Controls. If the upper surface is tilted, it is not perfectly parallel. A parallelism tolerance defines the allowable variation. So example, a surface is specified parallelism 0.05 or 50 micron datum A. This means the controlled surface must have within a tolerance zone consisting of two parallel planes separated by 0.05 mm or oriented parallel datum A. Then another one is perpendicularity. So this is the symbol of perpendicularity. Perpendicularity controls. So perpendicularity controls whether a picture is in 90 degree to a datum. Picture is 90 degree to a datum. For example, a hole drilled into a plate may need to be perpendicular to the plate, which is the datum A. If the hole is slightly tilted, so GD&T can control this tilt. Example, perpendicularity 0.03 mm datum A. So this controls the orientation of picture relative to the datum A. Then another one is angularity. What is angularity? Symbol. This. Angularity controls a feature. Angularity controls a feature at a specified angle other than 0 or 90 degree. For example, 45 degree plus or minus geometry tolerance. So a surface may need to be oriented. So 45 angularity symbol is. Angularity controls a feature at a specified angle other than 0 or 90 degree. For example, 45 degree plus or minus geometry tolerance. A surface may need to be oriented at an exactly 45 degree, so relative to a datum. Angularity establishes a tolerance zone around the theoretical exact angle. And another new topic is location tolerance. So let's discuss about the location tolerance. Location controls whether a picture is published. Location controls whether a picture is positioned. The major location control is position. The major location control is position. Symbol this. Position is one of the most important GD&T concept. It is commonly used for hole. It is commonly used for hole, shafts, slot, pin, bolt hole items. Then position tolerance. Suppose a plate certain 4 volts. The drawing might specify this to be. You need the hole to be the correct location. So traditional drawing might specify x50 plus or minus 0.1 mm, y30 plus or minus 0.1 mm. But this creates a rectangular tolerance. But this creates a rectangular tolerance zone. So GD&T position creates a cylindrical tolerance zone for a whole axis. For example, position dia 0.1 mm, A, B, and C. So means the whole axis must remain within a cylindrical tolerance zone of diameter 0.1 mm relative to the specified datum reference frame. Then y position is better than plus or minus dimension. Consider, so y position is better than plus or minus dimension. Consider x equal to 50 plus or minus 0.1. So y equal to 30 plus or minus 0.1. The whole can move within a square or rectangular region. The whole can move within a square or rectangular region. So within the position dia 0.20. The level location is circular or cylindrical region, and this can provide a more functionally appropriate tolerance and can sometimes allow more manufacturing variation while still ensuring assembly. So profile tolerances. Profile profile controls the shape of a line or surface. So profile controls the shape of a line or surfaces. Profile controls the shape of a line or surfaces. There are two profile controls, profile of a line or profile of a surface. So first one is profile of a line, symbol like this. So it controls the shape of a 2D cross section. Imagine a curved surface. The actual profile must remain within a specified tolerance zone around the theoretical exact profile. So it can control curves, arcs, contours, etc. So profile of a surface, symbol like this. It controls a completely 3D surface. This is very useful for automotive body plans, aircraft components, castings, mold parts, and complex machine surfaces. For example, an aerodynamic component may have a complicated curved surfaces. So profile tolerance can control the entire surfaces relative to its theoretical CAD shape. Then another one is a runout. That one new topic, runout. So runout is primarily used for the rotating component. Runout is primarily used for the rotating component. The two main types are circular runout, another one is total runout. One is circular runout, another one is total runout. So what is circular runout? Symbol like this. So commonly represented by the runout symbol. So circular runout controls the variation at individual circular cross section as a part rotates about a datum axis. So it can control radial variation and depend on the surface and axial variation. So example, a rotating shaft should not wobble excessively. So runout helps control this. Then total runouts. So total runouts control the entire. So total runout controls the entire surface at the component rotates. So it is more comprehensive than circular runout. So it can control the variations such as straightness, circularity, taper, and surface variation. So application. So commonly used for shaft, rotor, bearing surfaces, rotating component. Another new topic is the GD&T feature control plane. The GD&T feature control plane. A feature control plane, FCF. A feature control plane is the rectangular box containing a GD&T requirement. For example, position, dia 0.10, A, B, and C. So it contains geometric character symbol, tolerance value, diameter symbol if required, material condition modifier if applicable, datum reference. Then what is datum? A datum is a theoretical. So a datum is a theoretical exact reference used for a datum is a theoretical exact reference used to establish the location or orientation of a picture. Think a datum as a reference from which measurements are made. Common datum levels A, B, and C. For example, whole A, whole and then datum this. So here surface A can be used as a primary reference. Then datum reference plane. A part normally needs to multiple reference to completely establish a part. A part normally needs multiple reference to completely establish its position and orientation. They are called a datum reference plane. Datum reference plane. So usually we use primary datum, secondary datum, and tertiary datum. So often called A, B, and C. Then 3 to 1. What is 3 to 1 principle? So this is the one of the most important concept. A rigid body is 3D, has 6 degrees of freedom. So transition X, transition Y, transition 6. And then rotation about X, rotation about Y, rotation about Z. The datum system contains these degrees of freedom. The classic feature concept is called 3 to 1 principle. So primary datum 3 points. The primary datum typically establishes 3 contact points. Secondary datum 2 points. The secondary datum establishes 2 additional constraints, and tertiary datum 1 point. The tertiary datum establishes the final constraint. Thus 3 plus 2 plus 1 6 constraint, and this is fully locates a rigid part. So datum feature versus datum. This distinction is important. So datum feature, the actual physical feature selected as a reference. Example: surface, hole, shaft, shot. Datum, the theoretical exact reference derived from datum feature. For example, a physical surface is the datum feature. A physical surface is the datum feature. The theoretical XZ plane established from that surface is the datum. And another is MMC. What is maximum material condition? So MMC is one of the most important concepts in GD&T. So MMC means maximum material condition. It means the condition in which a picture contains the maximum amount of material. For example, for a hole, so smaller hole equal to material more. Smaller hole means more material. Example, hole size dia 10 to dia 10 to 10.20 mm. So maximum material condition of hole is 10. So maximum material condition of hole is 10. Hole is 10. So because smaller hole contains more material. For shaft, larger shaft, more material. Larger shaft, more material. Example, shaft 9.80 to 10 mm. 9.80 10 mm. So maximum material condition 10 mm. Then least material condition. What is least material condition? So LMC means least material condition. It is the opposite of MMC. For a hole, so larger hole means less material. Larger hole means less material. For shaft, smaller shaft means less material. For example, hole 10 to 10.20 mm. Least material condition 10.20 mm. Then another topic is RFC. Then another topic is RFC, means regardless of feature size. Regardless of feature size. RFC, regardless of feature size. This means the geometry tolerance does not change with a feature size. So unless another modifier is specified, many GD&T tolerance are interpreted as RFC under SAB 14.5. Then another one is bonus tolerance. What is bonus tolerance? This is a very important practical concept. Suppose a hole has 10 to 10.20 mm and position tolerance, so dia 0.1 m. The M means maximum material condition. So at M means dia 10 mm. So position tolerance for 0.10 mm. So the actual hole is manufactured as 10.15 mm. Then the hole, if the actual hole is manufactured at 10.15 mm, 10.15 mm, then the hole has moved away from MMC by 10.15 minus 10 mm, so 0.15 mm. Therefore, the hole receives 0.15 mm from bonus tolerance. The total position tolerance 0.10 plus 0.15. So 0.25. This is called bonus tolerance. And another one is virtual condition. What is virtual condition? So virtual condition is another important GD&T concept, especially for assembly. For an external feature such as shaft. So virtual condition maximum material condition size plus geometry tolerance. For an internal feature such as hole, virtual condition maximum material size minus geometry tolerance. For example, hole 10 to 10.20, position 0.10 mm. So at maximum material condition 10, virtual condition 10 minus 0.10, so 9.90 mm. So this mating feature must respect the application boundary created by the virtual condition. So maximum material symbols. So three important symbols are maximum material condition, this maximum material condition, maximum material condition like this, least material condition like this, least material condition, regardless phase, no modifier, regardless feature of size, regardless feature of size. Then size tolerance versus geometry, size tolerance versus geometry tolerance. This difference is extremely important. Size tolerance control the size, example 20 plus or minus 0.05. Acceptable size is 9.95 to 20.05 mm. So geometry tolerance controls geometry, example position 0.10. This controls where the picture is allowed to be located at part can the corrected size. but still have incorrect geometry. Then 4 element of GD&T called out. Then 4 element of a GD&T called out. A GD&T requirement commonly considered as picture, control, tolerance, datum. For example, position. So diameter 10 plus or minus 1, axiometric condition A, B, and C. So interpretation, position, geometrical characteristic, dia 0.10 means cylindrical tolerance zone, A means maximum condition, A means primary datum, B means secondary datum, C means tertiary datum. Then basic dimension. A basic dimension is theoretically exact. A basic dimension is theoretically exact. It is commonly shown inside a rectangular box. A basic dimension is theoretically exact. It is commonly shown inside a rectangular box. For example, 50 bracket. The dimension itself does not have a plus or minus tolerance. So instead the applicable GD&T control determine the allowable variation. So basic dimensions are very important for position. So basic dimensions are very important for position, profile, angularity, patterns, exact theoretical location. Then datum target. Sometimes a completely surface. Wait 1 minute. So my charger also very. So datum target. What is datum target? Sometimes a completely surface is not suitable for establishing a datum. A datum target can identify a specific point, line, or area used for picturing or inspection. This is especially useful for casting, forging, irregular surface, large component. So picture of a size. A picture of size is a picture that has a size dimension associated with it. Example, hole, shaft, slot, width, thickness. For example, dia 20 mm shaft. It is a picture of size. Then actual versus nominal versus basic size. What is the actual size? What is nominal size? What is basic size? Nominal size. The generally identifying size. Example, 20 mm shaft. Actual size. The size is measured from the measure component. Example, 19.96 mm. Basic size. The theoretical exact dimension includes GD&T. Example, that is the basic size. 50. Then tolerance zone. What is tolerance zone? A tolerance zone is the region within which the actual picture of must lie. A tolerance zone is the region within which is the actual picture must lie. Example, flatness, two parallel plates, straightness, two parallel lines, or a cylindrical zone depend on the application. Position, usually a cylindrical tolerance zone for an axis. Profile, a zone around the theoretically exact profile. So understanding tolerance zone is one of the key to understand GD&T. So datum order is important. Suppose the feature control plane says position, so dia 0.10 A, B, and C. The order matters. A means primary datum, B means second datum, C means tertiary datum. So changing the order can change how the part is considered and inspected. Then feature control plane example. Consider diameter this and position this and a diameter 0.2 M ABC. Suppose it controls a hole. So we can interpret it as the axis of the hole must lie inside a cylindrical position tolerance zone of diameter 0.20 mm at a maximum material condition within the location or orientation established relative to datum A, B, and C. If the hole becomes larger than MMC, it can receive the bonus position tolerance. then a position tolerance zone, then a position tolerance zone example, then the position tolerance example. Suppose bone dia 10 to 10.20 mm, 10 to 10.20 mm. Position, so dia 0.10 L, A, B and C. Case 1. So actual size dia 10 mm. Bonus size, so actual size dia 10.0. Bonus tolerance, this is the bonus tolerance. So this is the bonus tolerance. So total position tolerance 0.10 mm. So case 2, actual hole 10.10 mm. Bonus 0.10 mm. Total 0.20 mm. So case 3, actual hole 10.20 mm. Bonus 0.20 mm. Total 0.30 mm. The demonstrate why a MMC can provide manufacturer flexibility. Then form versus orientation versus location. What is form? What is orientation? Or location? This is one of the most easiest way to organize GD&T. Form. So what shape is it? Form. What shape is it? Example: straightness, flatness, circularity, cylindricity. Orientation. Which direction is it pointing? So what shape is it? Means a form tolerance. Orientation. Which direction is it pointing? Which direction is it pointing? Example: parallelism, perpendicularity, angularity. Location. Where it is. Example: position. Profile. What is the contour or shape? Example: profile of a line or profile of a surface. Then runout. How does it behave when rotated? How does it behave when rotated? Example: circular runout or total runout. Then quick GD&T classification. I will discuss or review it. Quick GD&T classification. Form in straightness. So form in flatness. Circularity form. Then cylindricity form tolerance. Parallelism orientation. Perpendicularity orientation. Angularity orientation. Position location. Concentricity location. Symmetricity location. Profile of a line, profile of a surface, profile, circular runout, total runout. So some modern standard and practices discourage using concentricity and symmetry when position or profile can provide a clearly functional control. Then what is concentricity? What is concentricity? So concentricity is a specialized control concerning the median point or median line of a picture relative to a datum axis. If it is often misunderstood, it is not simply make the two diameter share the same center. Let the two this is the simple, make the two diameter share the same center. So in many practical design, position or profile it will be preferred. Position profile is preferred because it is easier to specify, manufacture and inspect. And symmetricity. What is symmetricity? Symmetricity controls the median plane of a picture relative to the datum plane. So like concentricity, it is relatively difficult to inspect and its constant plays on more functional control, such as position or profile. So then commonly used GD&T controls. In real mechanical design, you will frequently encounter very common. So very commonly used: flatness, straightness, perpendicularity, parallelism, position, profile, runout. Less commonly used: circularity, cylindricity, angularity, concentricity, symmetricity. So example: shaft. Imagine a shaft. So possible GD&T requirement. So diameter, control size, dia 10 plus or minus 0.2. Straightness, control shaft or axis, surface straightness. Circularity, control each cross section roundness. Cylindricity, controls of overall cylindrical form. runout, control rotational behavior related to a datum axis. So, example, mounting plate. Mounting plate. Imagine a plate containing four holes. So, possible requirement. Flatness. Control the mounting surface. Control the mounting surface. Perpendicularity. Control side surface. Control side surface relative to the mounting surface. Position. Control fold locations. Hole diameter. Control the hole size. Profile. Could control a complex outer contour. And GD&T inspection. After manufacturing, inspector must verify GD&T requirement. So common inspection equipment include vernier caliper, micrometer, height gauge, dial indicator, bore gauge, surface plate, CMM, so optical measuring machine, so roundness tester, profile measuring equipment, and CMM. So CMM means coordinate measuring machine. A CMM measures the location and geometricity of picture in 3D. So it can measure whole location, angles, flatness, parallelism, perpendicularity, position, profile, runout, relationship. Same are widely used in precision manufacturing and quality control. GD&T and CNC machine. So GD&T is very important in CNC manufacturing. The general workflow is engineer drawing, GD&T interpretation, CNC process planning, machining inspection. For example, a drawing specifies pole diagram, position diagram, A, B, and C. The CNC programmer and a machine needs to understand the datum structure and required accuracy produced to hole correctly. And GD&T and manufacturing cost. One common mistake is specifying extremely tight tolerance everywhere. For example, flatness. So 0.001 means per micron. So maybe unnecessary for a nominal component. Very tight tolerance can require. So more expensive machine, more inspection, special process, longer machine time, higher rejection rate. So good GD&T means specify only accuracy necessary for the function of the part. GD&T and functional design. The best GD&T is based on function. Ask what does the part do? How does it assemble? Which surface locate the part? Which hole must align? Which surface must be parallel? Which surface must be perpendicular? Does the component rotate? What variation can the assembly tolerate? The select appropriate GD&T control. A simple real-world example. A simple real-world example. Imagine an engine mounting plate. It has one main mounting surface, four bolt holes, two locating holes. So you could define datum A, main mounting surface, datum B, one side surface, datum C, another side locating feature. There are four bolt holes. So position tolerance relative A, B, and C. Locating holes, tight position tolerance. Mounting surface. Mounting surface flatness requirement. Side surface perpendicularity relative to A. This creates a clear functional relationship. And how to read a GD&T drawing? How to read a GD&T drawing? So when you receive any drawing, follow the sequence. Step 1, identify unit, check mm or inch. Step 2, identify general tolerance. Look the general tolerance notes, identify datums. So find A, B and C. Understand which physical feature they are represent. Step 4, identify feature sizes. Step 4, identify feature size. Looks for diameter, width, thickness, length. Then 5, find feature control plane. Read each GD&T call out. 6, determine the tolerance zone. Ask, is it planar Is it planar, cylindrical, profile, or radial? Shape material modifier. So look for maximum material condition, least material condition, RFC, regardless feature of cell. Step 8. Understand functional requirements. Determine what the GD&T is trying to accomplish. Most important concept. Most important concept to learn fast. If you are learning GD&T and into mechanical engineering job, so recommend learning in this order. So level 1. So fundamentals. What is GD&T? Why GD&T is used? Basic dimension, tolerance zone, picture control frame, datums. Geometry controls, straightness, flatness, circularity, cylindricity, parallelism, perpendicularity, angularity, position, profile, runout, and advance. Maximum material condition, least material condition, regular feature of size, bonus tolerance, virtual condition, datum reference frame, 3 to 1 principle, composite tolerancing, projected tolerance zone, datum shift, and pattern requirement, functional gaming. GD&T introduces basic what is GD&T, a symbolic system. GD&T, a symbolic system used to define and control all level various part geometry. What is GD&T used to communicate functional requirement and accurately improve interchangeability and reduce unnecessary manufacturing tolerance. Why datum? What is a datum? A theoretical exact reference used to establish a location and orientation of feature. Why feature is control frame? A rectangular frame containing a geometric characteristic, tolerance value, and applicable modifier redundant. Why MMC? The orientation in which the feature contains the maximum amount of material. What is bonus tolerance? Additional geometric tolerance obtained within a specific device. Its MMC size. When geometric tolerance is specified at MMC. What is RFC? A regardless feature of size, if the geometric tolerance remains the same regardless of actual feature size. That is position tolerance. A geometric controls used to control the location or orientation of a feature commonly with the axis of whole or side. Very important difference. What is the difference between flatness versus parallelism? Flatness control the surface itself, does not need a datum. Parallelism control the orientation. Parallelism control the orientation of feature relative to a datum. So requires a datum. Example flatness 0.05. So flatness 0. Means the surface must flat within the 0.05 mm. So parallelism 0.05 mm means parallel 0.05 means A means the surface must parallel to the datum A within the specified tolerance zone. And perpendicularity versus angularity. Perpendicularity versus angularity. So perpendicularity control 90-degree orientation. Control 90-degree orientation. Angularity control a specified angle such as 30 degree, 45 degree, and 60 degree. So perpendicularity 90-degree, angularity specified angle. What is the difference between circularity and cylindricity? Circularity control individual circles, circular cross section controls individual circular cross section. Cylindricity controls the entire cylindrical surface. Therefore, cylindrical circularity one circular section, cylindricity completely cylinder. So, what is the difference? What is the circular runout versus total runout? Circular runout versus total. Circular runout control each circle section individually at the part rotates. Total runout controls the entire surface of the part rotates. Therefore, total runout is more comprehensive. Most important GD&T idea. Don't memorize a symbol alone. Instead of always ask what function of the part am I trying to control? For example, hole must be a pin position. Hole must be a pin position. Surface must be flatness. Surface must be at 90 degree perpendicularity. Surface must have parallelism. Part rotates runout. Complex curved surface profile. This makes GD&T much easier to understand. In one page, GD&T cheat sheet. Straightness, it is straight. So GD&T and main question. Straightness, is it straight? Flatness, is it surface flat? Circularity, is each circle round? Is each circle round? Cylindricity, is it cylinder? Correct. Parallelism, is it parallel? Parallel. Perpendicularity, is it 90 degree? Angularity, is it the specified angle? Position, is it the correct location? Profile of line, is it 2D contour correct? Profile of surface, is it 3D surface correct? So circular runout, so does each section run through? Total runout, does the whole surface run through? So final understanding, you can remember GD&T with 5 questions. For what shape is it? So for what shape is it? What shape is it? Straightness, flatness, circularity, cylindricity. Orientation, how it is oriented. Parallelism, perpendicularity, angularity. Location, where is it? Position. In profile, what is the contour? Profile of a line, profile of a surface. Runout. How does it behave while rotating? Circular runout, total runout. So and then learn the supporting concept, datum. So datum control plan, basic dimension, MMC, LLC, RFC, bonus tolerance, actual condition, datum reference plan, inspection. So this is my part 1 video. So let's discussion about my part 2 video. And this is my part 2 video, and this video I think you understand what is the GD&T symbol. So let's start about first is form tolerance, second is profile, third one is orientation. There are so many tolerance you read in before part 1 video. Form, profile, orientation, location, and runout. So form tolerance first one, straightness. So control the straightness of picture in a relation to its own perfect form. Flatness. Control the flatness of a surface in relation to its own perfect form. Then circularity. Control the form of a revolved surface in relation to its own perfect by independent cross section. Circularity, like circularity, but apply simultaneously to entire surface. Profile of a surface. Profile of a surface. Control the size and form of a picture. Control the size and form of a picture. In addition, it controls the location and orientation when datum reference frame is used. Profile of a line. So similar to profile of a surface applies to cross section of a picture. Perpendicularity controls the orientation of a picture which is normally perpendicular to the primary datum of its datum reference frame. Angularity control the orientation of the picture at the specific angle in relation to the primary datum of its datum reference frame. Parallelism control the orientation of picture which is normally parallel to the primary datum of its datum reference frame. Position control the location and orientation of a picture in relation to its datum reference frame. Concentricity control the concentricity of a surface of a revolution to central datum. Symmetricity control the symmetry of two surfaces about central datum. Control circularity and coaxiality of each circular segment of surface independently about coaxial datum. Total learner control circularity and straightness, coaxiality and temper of the cylindrical surface about coaxial datum. A symbol of the GD&T symbol. So first one is L round, least material condition, M round, maximum material condition, T round, target zone, P round, projected tolerance zone, F round, free state, then diameter, radius, spherical radius. So spherical diameter, controlled radius, statical tolerance, basic dimension, reference dimension, places. Another one is the dimension origin, counter bore, countersink, depth, all around, between, target point, conical taper, slope, square. Again, you can read about that one time. They all are symbols. So I will mention. So that's all about for me. So this is my part 2 video. So let's discussion about in part 3 video. So this is my part 3 video. So you can clearly understand about that geometry, dimensioning and tolerances. See that image, then you can clearly understand that. See one time I will show you that image. Wait 1 minute. Wait. So read. So this is the geometry dimensioning and tolerance. So back to remember what is maximum material condition. So what is straightness. So first symbol in as shown in the drawing, tolerance zone, maximum material condition, datum used, function used, and tolerance safety. So maximum material condition. See that is the image. This is the maximum material condition. This is the least material condition. RFC, projected tolerance zone, and statical tolerance zone. Pre-state, datum symbols. So excess dimension, and this is the diameter tolerance zone. So see that is the all the image you can read and write that image. So then after that you can clearly understand about that topic. So what is maximum material condition, what is least. So in that total video is understand about that. So if you want to read all these topics, then you can clearly understand about that. So one time you read about what is picture control frame. So he also explain what is basic sentence of structure. So he also explain what is the bonus tolerance. He also explains. So you can read about that tolerances. What is MMC? What is functional gauges, devices. So bonus tolerances. Shift as a datum picture. Virtual condition. So that's about this video. So external picture, that is internal picture. So this is all are you write it. So you can read and write it. So let's discuss about my part 4 video. This is my part 2 video. You can read and understand about that thing. So let's discuss about my part 4 video. So this is my part 4 video. So discussion about what is engineering drawing. So first of all, what is drawing? So what is drawing? So it is the graphical language of engineer. It is the graphical language of engineer. So designer or engineer develops their idea, structure, and machine parts with the help of drawing. Geometrical drawing, circle, rectangle, triangle, pyramids, geometrical drawing, mechanical drawing. So it is the art of the representing mechanical object like cylinder, machine parts, etc. Civil, dam, beach, printing, etc. Electrical, motor, generator, poles, etc. Sketching, it is freehand expression of the graphic language. So it is very easy to draw in sketches. So it is very easy to draw in sketches without the use of instrument. So this is the title block. You can see that is the image of the title block. Designer, draft, check, standard, output. So so let's discuss about another topic. So what is size? What is size? What is seat size? What is seat size? So designation, trimmed size, untrimmed size. So A for 210 into 210 into 297, untrimmed 240 into 300. A3 297 into 420, and A2 420 into 594, 594 841. So what is scale? What is scale? The scale of drawing shall decided. The scale of drawing shall decided the size of the sheet to be used. The scale of drawing shall decide the size of sheet to be used. So ISI recommended scale, full scale 1 is to 1, full scale 1 is to 1. So reduced scale 1 is to 2, 1 is to 2.5, 1 is to 5, 1 is to 10, 1 is to 20, 1 is to 50, 1 is to 100, 1 is to 200. A large scale 100 is to 1, 50 is to 1, 20 is to 1, 10 is to 1, 5 is to 1, 2 is to 1. So what is line? What is line? So 2 points are meeting is called a line. 2 points are meeting. So the 2 points are meeting is called a line. So lines are three types. One is thick, so point 0.15, 0.5. One is medium, so 0.3. Another one is 3, 0.2. So ranges 0.18, 0.25, 0.35, 0.5, 0.7, 1.0, 1.4. Then let's discussion about line. In that, I think in designing there are so many types of lines are there. First one is the object, then the type and conversation. So object, outer line, or object line. So type continuous thick line. So this type of 0.5 is the conversation line. Construction line, continuous thin line, 0.25 this is. So hidden line, so dash line, this is 0.35 thickness. Center locus line, thin line, 0.35 line, so this is the center thickness line. Dimension line, thin line, so this is the dimension line. Extension line, thin line, this is the extension line. Section line, thin line, this is the section line. Short break line, this is the freehand thin line. Long break line, this is the zigzag line, this is the zig line. Cutting plane, this is the cutting plane. Thin and thick at the end, dotted line, so double dash line. Leader line, this is the leader line. Arrowhead, this is the arrowhead. 3 is to 1 is the arrowhead. So thick 0.15, thin is 0.35. Yeah, it is 35. Then what is what is outer line or object line? What is outer line or object line? What is outer line or object line? So outer line or object line. What is outer line or object line? So these continuous thick lines used to represent the outer line or the overall shape of the object. Used to represent the outer line, the overall shape of the object. Every edge or surface that is visible is presented by that line. Is presented by that line. Construction line. These are the continuous thin line. These are the continuous thin line used for projecting and transforming location from one view to another. Used for construction purpose and useless. These lines do not appear in finished drawing. Then hidden line. These are dashed line. Hidden line. These are dashed line. Used to show hidden part or portion. Used to show hidden part or portion of the object. It is used to represent feature that cannot be seen in the current view. This is the hidden line that cannot be seen in the current view. Another one is the center line. What is center? What is center or locus line? What is center or locus line? It is used to represent the center or locus of the object. So center line should begin and end with a long dash. So center line should begin and end with long dash. It is used for the symmetric parts. It is used for the symmetrical parts, circle, cylinder, board, etc. Then see that is the image of the center line or locus line. So another one is the dimension and extension line. These are the thin lines, so dimension and extension line used to represent the dimension of the object. So dimension line have arrowhead. The dimension line have arrowhead, and the both ends have always drawn with extension, and both ends always have drawn with extension. This is the extension. This is the driven line. This is the dimension line. This is the extension line. Then another one is section line. What is section line? These are the thin continuous line, uniform placed. So uniform place spaced. Used to show a part in the section. Used to show in part in section. Uh, so these lines are usually drawn at an angle of 45 degree. These lines extremely edges to edges of the surface in which these are drawn. This is the section line. Another one is the short break line. It is continuous thin, a thin freehand line. So used to show a break of an object or to indicate irregular boundary of an object. These result in saving space-time. Long break line. Then another one is this is the long break. So what is long break? So it is continuous thin with zigzag line used within the long break extend over a considerable length of drawing. So this is the long break line. This is the short break. This is the long break. Then what is cutting plane line? What is cutting plane line? This is the cutting plane. See that is the image of the cutting plane line. So same as the center line, but the extra thick at the start and end line. So used to show the edge of the cutting plane where the object is being sectioned to show the hidden details. And detour line. What is detour? Detour line. It is double dash line. What is detour line? It is double dash line. Used to copy a part or portion or object. Then phantom line. So this is the phantom line. So detour line. So see that is this is what is phantom line. This is the phantom line. What is chain line? This is the chain line. And another new topic is engineering standard. So three category of engineering standard. One is international, one is national, another one is company. There are three standard in all over the world. One is international, another one is national, another one is company. So international system of unit SI, which is based on the meter. So millimeter, which is based on the meter. Millimeter mm, the commonly SI unit to measure in the engineering drawing. Note all dimensions are in mm. So bottom to left corner outside of the title box. Then what is dimension? What is dimension? What is dimension? So it is a numerical value. So what is dimension? It is the what is dimension? It is the numerical value expressed in the clear units of measurement. This is the dimension used to define the size, location, orientation. And two types of placing of dimension. One is angle system, another one is unidirectional system. Note. So use only one dimension system is in one entire drawing. So use only one dimension system in entire drawing. The aligned and unidirectional system should not be mixed together on drawing on one single drawing. The unidirectional system has now the unidirectional system has now replaced the aligned system in most industry. So let's difference about that unidirectional system and aligned system. So dimensions are placed vertically irrespective of dimension line. Dimensions are placed perpendicular to corresponding dimension line. All dimensions can be read from bottom of the drawing. Here, horizontal dimension here. Horizontal dimension can be read from the bottom of the drawing, where the vertical dimension can read from the right side. So dimensions are placed breaking the dimension line of the middle. Dimensions are placed above the dimension line without the breaking line. See that is the image of the unidirectional and aligned dimension system. And this is let's discuss about GD&T and geometrical dimensioning and tolerancing. So GD&T stands for geometrical dimensioning and tolerancing. It is a symbol. So it is a symbol of system. It is a symbol. It is a system of symbols, rules, and definition used to defining the geometry of mechanical parts. It is used to define size. It is used to define size, shape, form, orientation, and the location of feature of a part. So dimension is the geometric characteristics of size which is specified by length, angle, location, and center distance, etc. Then why GD&T used? So used for drawing study. So why GD&T used for this drawing study? Used for dimension control, tolerance mention କରିବା ପାଇଁ, achieve to accuracy. It is two types. One is datum picture, another one is tolerance picture. One is datum picture, another one is tolerance. One is datum picture, another one is tolerance picture. So datum picture. So it means surface आम master to start करछे जहाँ पे master धरछे ताको हमें डाटा पिक्चर कहबा जो surface master माने कि second surface रो tolerance maintain करथाव ताको डाटा पिक्चर कहबा और सही surface second surface रो डाटा पिक्चर हेबो tolerance picture. It is the type of tolerance picture जोटा tolerance mention होइथिबो. That is the tolerance picture. See, that is the image of the datum picture and the datum picture and tolerance picture. See, that is the image. How to show the datum picture? See that is the show. There are three factors are there used: datum letter, datum triangle, datum surface. And how to show the tolerance picture? So six factors are there used. Six factors are there used. So leader line, arrow line, leader line, arrow line. So datum letters, tolerance value, tolerance symbol, tolerance surface. So symbols. So it is two types. One is a single picture, another one is a related picture. What is single picture? No datum are used. What is a related picture? So datum are used. Datum are used or related. Then single picture. Then what is single picture? So single picture has straightness, flatness. Single picture has straightness, flatness, circularity or roundness, cylindricity. What is related picture or datum picture? What is related picture or datum picture? Then you see that is also profile of a line, profile of a line, profile of a surface. So example of a related picture, and first one is cylindricity, flatness. These are the say profile of a line, profile of a surface. That is the single picture. What is reference to a related picture? So seven tolerances are the related picture: parallelism, perpendicularity, and squareness, and angularity, position, concentricity, circularity, coaxiality, sequencentricity or coaxiality, symmetricity, roundness. That is a related picture. Note always remember when you read GD&T or CET, what is this is single picture, what is the single picture, what is the related picture. See, straightness as this. So permissible straightness in 80 micron. See, that is the permissible tolerance is 80 micron. Flatness. See, so permissible flatness is 180 micron, etc. Parallelism. See, that is the parallelism. So first surface का parallelism, then datum, and then D surface सहित what you see. So what is the parallel perpendicularity tolerance? So first surface का perpendicularity a surface note. Latest standard, what is standard? Latest standard ASME Y14.5 2018. So what is ASME? American Society of Mechanical Engineering. Then classification of GD&T. Classification of GD&T. There are divided into five groups. One is form, another one is location, another one is orientation, profile, runout. Form, location, orientation, profile, runout. Form tolerance. First one is form tolerance. One is straightness, flatness, circularity, cylindricity. Straightness. So characteristics in straightness. GD&T symbol these. So control type for datum not required. Definition. So control the straightness of a picture in relation to its own own perfect path. Let's do own perfect path. So check by dial gauge. Check by dial gauge. So rectangular part or circular part. Note any type of job you check. Any type of job you check. Roundness or circular is not to be not to be dear not to be data or not to be dirt or mega तेढ़ा not to be तेढ़ा मेढ़ा ना हो तो दरकार so actually straight है तो दरकार so note any type of job you check or focus not to be तेढ़ा मेढ़ा ये तेढ़ा मेढ़ा है उन्हें तो दरकार accurate straight है दरकार and this tolerance maintain हो and flatness. So geometrical characteristics that is flatness, GD&T were this. So that is the characteristics for which type of tolerance, form tolerance, which type of datum very not required definition. So flatness of a surface indicating that. So flatness of a surface indicating that all the points along the surface lie in the same plane. All the points in the surface lines, which are all the flatness surface indicating that all the points along the surface line in the same plane. So any part you check, all are same value have. So not theta meda. So that is the whatever is mentioned that is on the other. And another one is say roundness or circularity. So that is similar circularity. GD&T tolerance is this circularity. Characteristic tolerance, which tolerance, form tolerance. So datum not required. Definition. Circularity describe how close an object should to be true circle. How close an object to be a true circle. True circle. So check by an vernier with a hole around 360 degree whether the fluctuation is there called circularity. See that is the so perfect hole have darkar not edge line or which another one is cylindricity. What is cylindricity? Cylindricity, that symbol of the GD&T is and diameter not required. Definition: the cylindricity symbol describe close an object. The cylindricity symbol describe close an object. So conform to a true cylinder. So cylindricity particular cylindricity particular point or circular ଉପରେ check କରୁଥିଲେ but cylinder total check. Cylindricity. So cylindricity particular point or circle over check କରୁଥିଲେ but cylindricity total check. Note any cylinder inside and outside diagram center the same होइଥିବା ଦରକାର. Any cylinder inside and outside center same होइଥିବା ଦରକାର. Then see that is the best. Then another one is profile. So a profile of a line or profile of a surface. Profile of a line. So this is the profile of a line. GD&T this symbol datum not required. Definition: the profile of a line requirement indicates whether the curvature of a designated part is made to its design, same particular part or profile measurement. And measure it. So this is the profile of a line, then profile of a surface, same profile of a surface, GD&T symbol this. So geometrical tolerance profile datum not required. Definition: profile of a surface describes a 3D tolerance zone around a surface. Check all the surface helps by height gauge CMM message. And another one is orientation. There are three types of orientation. One is angular in that orientation. Three tolerance are there. One is angularity, perpendicularity, parallelism. Angularity. See that is the image of the angularity. GD&T this symbol. And geometrical tolerance orientation that required. So angularity specify the accuracy of an angle to the reference plane or line. Angularity specifies accuracy of angle to the reference plane or line. Then another is perpendicularity. So perpendicular geometrical characteristics, perpendicularity, GD&T, this tolerance or orientation datum required. So perpendicularity may defined as a condition. So perpendicularity may be defined as a condition of a surface or axis at 90 degree to the datum, then r axis, datum to r axis or axis. So 90-degree angle may କରୁଥିବା any point. That is the perpendicularity. Another is parallelism. So this symbol, geometrical tolerance, orientation, D is the datum required. So the condition of a surface, parallelism, the condition of a surface line or axis, which is equidistant at all form of a datum plane or axis. Following this location, position and concentricity. Position, so geometrical characteristic position, geometrical and this, and characteristic location, this is datum required. And definition, the position specified desired location. This is the desired location. Profile of surface, geometrical profile of a surface, geometrical this, and the profile of not required. So profile of a surface. So profile of a surface describes a 3D tolerance around the surface. Profile of a line and check the dial gauge. So then this is then another one is the location. Position and concentration. Location, position and concentricity. What is position? See, that is the position. Characteristics, location, and atom required. Definition: the position specified desired location. The position specified desired location. The position specified desired location, as well as allow deviation to the position of a feature or on a point. So ଯେକୌଣସି ପାର୍ଟର ହୋଲ୍ ଯେତିକି ରେଫରେନ୍ସ ନେଇକି ପ୍ଲେସ୍ କରିବା ପାଇଁ ଚେକ୍ କରିବା and ହୋଲ୍ ସାଇଜ୍ କେତେ, that is called position. That is called. Then another is concentricity. Concentricity or coaxiality. So concentricity is the symbol of concentricity, characteristic, location, and atom required. Concentricity is the coincidence degree of the center of two circles. So note, so circle or axis the center check करियो, axis same or axis same or any fluctuation is there, you can check it. So note one axis ऊपर center हेबा दरकार. Symmetricity, geometrical characteristic, this is the symbol datum required. Division symmetricity is that the condition whether the median point of all of corresponding located points and two or more feature surface are contact with the axis or center plane of a datum feature. So exactly both side one shape. So upper, so flatter curve, so lower flatter curve. Another one is runout. So another is runout, circular runout, total runout. Circular runout, this is geometrical circular runout, this geometrical characteristic runout, datum required. A circular runout specifies how much the feature can vary in a relationship to the refer part, as well as the part is rotated around the axis. It is the circular runout. This is the circular. Then another one is total runout. This is the total runout. The runout and required. Definition: if the component is rotation between center, if the component is rotation between the center and its runout is represented for the entire length of the component, it gives the total runout. So check all the surface save in the circular runout. And all are symbol I will explain in basic before video, then you can clearly understand about that temperature control frame. So once we see pattern also I am explaining before video. So this is my part 4 video. I will complete in part 4 video. So let's discuss with another video, and that video you can clearly understand about in GD&T. And this is my part 5 video. So you can read and understand. It Datum is a plane and straight line and a point that is used to reference when the processing material or measuring the dimension of a target. So to position versus true position. Think a dart board. Position versus true position. Think of a dart board. So position versus true position. So position tolerance, measured axis, true position. So see, that is the image. You can read and understand about. And root over this is to this. This is you can understand about that. Then you can see that image. Then you can clearly understand. Then a plane of projection. So that is an imaginary third image or picture plane. Is imaginary flat plane upon which is the image is projected. So see, that is the man is standing here and the image is image and the object is back and the image is created in the front side. So projection is understand orthographic projection, oblique projection, and perspective projection. In orthographic projection, multi-view. One is a multi-view or multi-view plane. Angular projection. First angle in orthographic, first angle and third angle. Orthometric, so isometric, diametric, asymmetric. See that they mean. See, then you can clearly understand about that. And in engineering time often have two producers. One is a front view, one is side view, another one is front view, side view, top view. There are three view in orthographic position. So orthographic position, there are two angles. One is first angle method, and is third angle method. So see, that is the quadrant system, orthographic position. And in the quadrant system, y plane or vertical plane, x plane or horizontal plane. See, that is the first quadrant and the second quadrant, third quadrant, fourth quadrant. And see, this is the rule of the orthographic position. To draw the projection of 3D object on the 2D plane, the horizontal plane is rotated to the clockwise direction. Then see, that is the first angle projection. This is the first angle projection. See, the right side view, this is the top side front view, this is the left side view, this is the top view. Now see, that is the profile of the surfaces. See, that is the image. This is the third angle method. This is the third angle method. See, that is the image. The third angle method. Third angle. See the symbol. This is the symbol of the orthographic position. First angle and third angle. And see, that is the image. So symbol that first angle method. And this is the third angle method. So this one also again you can see that is first angle and third angle. And this is the picture control plane. You can read and read about that. This is the picture control plane. And this is the modifier, maximum material condition, least material position tolerance, free state variation, tangent, relative. Maximum material condition, least material free state. So modifier, maximum material condition, least material. Maximum condition, this is the symbol you can read and write about it. So least material condition, maximum material condition for this shaft. Least material condition, maximum condition for this shaft. See, that is the image. Put it I plot 10 plus or minus 0.5 mm. So least material condition. So least material condition for this shaft. So 9.5. In maximum material condition 10.5. So in the least material and maximum condition of both ID that 10 plus or minus 0.5. So ID 9.5 is the maximum material condition. Least material 10.5. So bonus tolerance. This is the bonus tolerance. You can read about, write about the what is bonus tolerance. So this is the bonus tolerance. So say you can read and write that and see, find that image also. You can see it. This is the bonus tolerance. bonus maximum material condition minus actual size. That is the bonus, and then the flatness becomes this. Then least material condition. So this is the least material condition. You can find about that in your actual size how much least material condition. The maximum condition, least material condition. You can see that image. So this is my part 5 video. So let's discussion about my part 6 video. This video is very important for every quality engineer. So let's discussion about GD&T. GD&T technical language, quality parameter, parts and functions in GD&T precise, very engineer simple, to target is not on a heavy program. So this is the history of the GD&T. So I will this in that video I will just scroll down. You can read about all the pictures, whatever you want. You can read out. See that in the web what is GD&T. So you will clearly explain in that video what is GD&T. What is GD&T. You can read about that. That is AMS, American Society of Medical Engineering College, then ISO, International Organization for Standardization, used for rest of the world. International Organization for Standardization, and the basic dimension. So see that is the basic dimension. That is the paper time you reduce the amount of nodes, dimension, tolerance required for drive. Now this is a symbol you can easy for designing or quality space or driving force behind the GD&T. Driving force behind the GD&T. So GD&T for designing and quality engineering. GD&T for design. GD&T for designing and quality engineering. Topic cover feature of size, feature control caps, datum, feature control symbol, datum placement, uh, uh, arting, datum, feature control cap, selection of datum, basic dimension, feature of size. This is the picture of size. You can read about that. And this is the picture of size. This is the picture of size. The picture control tabs. This is the picture control tab. See, a picture control term is used to convey the geometrical tolerance for a picture. The geometric tolerance and geometric tolerance of datum reference. So what is datum? A datum is a theoretically exact axis plane for the axis location of geometric characteristics part which are established. So point to consider for the selected selection datum. See that is the point to consider. So datum reference symbol. This is the datum reference symbol. So datum placement of plane surfaces. So datum placement of size picture. So attaching datum picture of control planes. Attaching datum picture of control planes. Then second datum. This is the second datum. Section of datum. Section of datums. This is the section of datums. So this is the section of datum. See that the image. The basic dimension. What is basic dimension is an image value used to describe the theoretical exact size, profile, orientation, or location in part picture using position or rotated poles. And tolerance type of common mistake without basic dimension. Better control basic dimension. Geometrical characteristics. For geometry 5, 4 to 5 geometrical characteristics. Orthogonal geometry or orthogonal see that is the form tolerance, flatness, straightness, or velocity. It's the orientation tolerance, angular parallelism. It's the runout tolerance, circular runout, total runout. It's the profile tolerance, the profile tolerance, provided the surface provided to light. Interlocation tolerance, position, eccentricity, symmetricity. And this is all about the geometric characteristics. Topic cover geometric tolerance, so rules of GD&T, LMC, RFC, datum reference, and do a group product operation and flatness. Geometrical tolerance, geometrical tolerance. See that is the image of the geometrical tolerance. And geometrical tolerance. See that is the image of geometrical tolerance. The rules of GD&T, so limit size of the rule, method condition of the rule, PC diameter rules. See rule and limit size rule. See this is the limit size of the rule. Given rule and the geometric form of which are may vary so long as stay within the limits. It's the maximum material condition. Maximum material condition. The maximum condition is the condition. See that is the image of the message and this material condition. See that image you can clearly understand about that maximum condition and this material condition. Rule the pitch diameter rule. The geometric form of picture may vary so long as stay within the limit of cell size tolerance. So, for threaded rule, for VS balancing, for VS balancing, what is the modifier? Maximum condition, least material condition, balancing, can be characteristic of the picture size. Maximum material condition, principle, least material condition, principle. Regardless picture of size and datum preference. So when an orientation pronoun profile location tolerance must be related to a datum. A datum reference is used. So datum reference, there may be maximum 3 datums that are listed in the order of the reference. First datum is primary, second and secondary, and is the secondary, and the third one is tertiary. So the do and don't decouple display. Then do and don't decouple display orientation. So runout, see that is the runout, and that is the profile, and that is the location, and that is the form tolerances. First one is a flatness. Flatness symbol like this. Flatness, tolerance limit, tolerance limit. Flatness is a read it. Flatness, you can read it, this all these things. This one also how to inspect for the flatness. Easy inspect. Then the presentation flatness drawing. Then straightness, see that is the image of the straightness, you can read about this straightness symbol. And that one also straightness, you can read about that. And that one is the straightness of cylindrical visor. And straightness of cylindrical visor. Straightness, cylinder of the axis, straightness. Application of maximum condition to axis, straightness. Straightness of hard surface. Then inspecting for straightness. Inspecting for the straightness. This is the inspection of the straightness. Representative straightness in a drawing. Then geometry dimension topics cover circularity and cylindricity. That is circularity. This is the circularity. You can read and write about this on this image. Circularity. And the circularity, see that is the image of the circularity. This is the circularity thumb rule. You can read and write about the circularity. This is the circularity of the thumb rule. This is the inspection of the circularity. This is the inspection of the circularity. Then the representation of circularity in drawing. Then another one is cylindricity. See that is the cylindricity drawing. You can read and write in everything that is cylindricity. And let's see how to check in cylindricity. Check cylindricity. Let me see the cylindricity. Here represent as some cylindricity in drawing. Topic cover orientation tolerances, perpendicularity, angularity, parallelism. Orientation tolerances, perpendicularity, angularity, parallelism. Perpendicularity is the perpendicularity. Another is the perpendicularity is the perpendicularity. Perpendicularity is the elements of perpendicularity. Perpendicularity, see that is the image of the perpendicularity. Perpendicularity, see that is the way you can write about read and write in everything that is the perpendicularity. Inspection for perpendicularity, see on the right side, inspection for perpendicularity. See this are also perpendicularity, you can check it. See this is the perpendicularity, you can say. So representation of the perpendicularity drawing. And another one is angularity. So see that is all information about that angularity. You can read and write this all these things. Angularity. Angularity. See that is the angularity. The inspection for the angularity. See that is the angularity. You will inspect it. And representation of angularity in drawing. And parallelism. What is parallelism? You will read and write about that parallelism. What is parallelism? Parallelism symbol. So the parallelism you can write in everything. Parallelism. See that is the parallelism. Parallelism is everything. You can write about that image. And inspecting for the parallelism. How to inspect that is parallelism. This one also parallelism. How to inspect. Represent the parallelism in a drawing. Parallelism in drawing. Topic cover runout tolerance, circular runout, total runout. So runout tolerance, circular runout, total runout. So runout tolerance is the runout tolerances. This is the circular runout tolerances. The total runout tolerances. Is checking for runout tolerances. Representation of the runout in drawings. Profile tolerances. Profile tolerances. So profile tolerance, there are two types: profile of line, profile of a surface. The profile of a surface is the profile of a surface. Is the profile of a surface. Profile of a line is the profile of a line. The method specifying profile tolerance, bilateral or equilateral, divided. So see that is the bilateral and equilateral. Method expressing profile tolerances. Effective unilateral tolerances. It's all around tolerances applied to the cursor. So they're checking for profile tolerances. A representation of profile tolerance in drawing. Then coplanar surfaces. Coplanar surfaces. Coplanar surfaces. Location tolerance, position, concentricity, and symmetricity. Position is the position of the tolerance. Is the position of the tolerance. Meeting parts, floating and fixed fastener. Floating fastening, fastener. Floating fastener. So fixed fastener. Fixed fastener. So positional tolerance on an MMC basis. So positional tolerance on an MMC basis. Positional tolerance on an MMC basis. Positional tolerance with the datum is at MMC basis. Projected tolerance zone. This is the projected tolerance zone. Projected tolerance zone. Control of coaxial picture. control of coaxial picture, measuring position tolerance, representation of the position tolerance in a drawing, representing the position tolerance in drawing. Location tolerance is the location position or percentage density location tolerance. Percent density is the percent density. Percent density is the percent density. The measuring of the percent density. Representation of percent density in drawing. Then symmetricity is the symmetricity. Measuring symmetricity tolerances is the symmetricity. I will use that symmetricity. You can see that is the representation of symmetricity in drawing. Then geometric characteristics. So exercise 1 is the exercise 1, and this is the exercise 2, this is the exercise 3, this is the exercise 4, this is the exercise 5, this is the exercise 6, this is the exercise 7. So I will discuss in everything and read and write that in everything, then you can clearly understand about it. This is the one of PDF book, so you can read and read about everything and clearly understand about it. So important, first, second, third, fourth, and read, explain and clear. You can read it and clearly understand about it. You can just read it.